coming up next, we have two guests. We have Raul and we also have Jeremy. And Raul and Jeremy are going to come on and they're going to talk to us about diving into the world of big data with .NET for Apache Spark. So, gentlemen, I'll let you go ahead and take it over.
Sounds great.
Sounds great. Hello, everyone. My name is Rahul Podraju. I'm from the Azure Data team, and today I'm joined here by my colleague, Jeremy Lickness from the .NET Data team. We hope you're having a wonderful day so far. Today, we are going to be talking about the role of .NET in big data. And before we start diving into this new library that we have built called .NET for Apache Spark, let me start with something more fundamental. Let's start with the basic question, what is Apache Spark and why are we actually talking about it today? So Spark is a unified and a parallel data processing framework. What does this mean? Imagine you're writing a console application and when you hit something like F5, it usually ends up running on top of your machine. But in this particular case, Spark is a system that allows you to take the exact same code and run it on a cluster of machines. When would you use this? Well, when the amount of data that you're trying to process is increasing in size, especially when it starts hitting into gigabytes or terabytes, then you would need a cluster of machines to start processing that. One of the nice things with Spark is it comes with this thing called as the Spark core engine, which attempts to unify batch processing, interactive SQL. It does a bunch of real-time processing. It also allows you to do things like machine learning, deep learning, and also graph processing. And all of this works seamlessly well in the form of different kinds of libraries that are built on top of this Spark core engine. That way, once you learn something, pretty much you can use the same knowledge in order to do anything inside Spark. And one of the questions that you might be wondering at this stage is, hey, yes, we are targeting .NET developers. Why didn't we just go ahead and build something ground up from Spark? Hopefully, I can convince you now. So Spark is an open source project. And one of the great things about Spark is it's heavily popular. Whether you take it in data engineering or data science community, it has a pretty large following on GitHub. It's all open source. You can go look at the code. And if you start looking at the number of people contributing to Spark, it's roughly about 1,600 people. And it's all the goodness of open source. And pretty much if you want to understand something, you can just go dive right into the code. And at that stage, what we also ended up seeing is there was a tremendous amount of demand that came inside Microsoft from all of our teams, including large teams like Office, that wanted to get into the world of Spark, but not having to relearn like a new programming language like Scala or Python. And this is the basic reason that we started investing in .NET for Apache Spark. So what does .NET for Apache Spark provide you with? Well, it provides you with first-class support, and I really mean first-class, and I'll show you hopefully with some examples to convince you that it's really first-class. It provides you with support for Spark data frames, which give you the full power to leverage the underlying Spark's optimizer without having to worry about manually optimizing code with hand. It works seamlessly with the major versions of Spark that are out there in production, like in many companies, essentially. To name this, it works with Spark 2.3, 2.4, and 3.0. It targets .NET Standard. One of the nice things we get by targeting something like .NET Standard is the nice thing that now your code is cross-platform. If you want to run it on .NET Framework, feel free to do that. The recommended approach is .NET Core 2.1 plus. And majority of the cloud providers anyway support .NET Core, so you should see some nice goodness coming out of it. And finally, one of the great things is the library .NET for Apache Spark also supports both kinds of computation. One is batch as well as streaming, and it includes first-class support for Spark structured streaming, which is one of the nice things that you end up getting. So if you have scenarios where you have real-time data coming into your compute clusters, you can go ahead and start using .NET for Spark in production pipelines today. And one of the nice benefits of building a layer on top of Spark is if Spark can talk with any data source, think of Azure or maybe Amazon's S3 or even like Cosmos DB, you name it. One of the nice things is because we leverage everything from within Spark, If you see some data source working perfectly with a Scala example or a Python example, you can use pretty much the exact same thing in the .NET world as well. So let me just briefly start explaining what does the programmability model look like. Step one, when you start writing this, most likely this statement will become your best friend. The first thing that you would end up doing is you would end up creating a session. So a session, think of it as being analogous to requesting some kind of machines or cores in order to run your application itself. So in this case, I'm saying like Spark session, go ahead and get or create a session for me. In step two, what I would end up doing is I would create something called as a data frame. You can think of a data frame as, if you're familiar with SQL Server, you can think of it as providing the table name essentially, wherein you say select something from the table. This is analogous to saying Spark, go ahead and read this particular JSON file. And the name of the JSON file is input.json. And you're basically specifying that this is my data provider, which is JSON. In step three, you get the goodness of C#, and this is what really made the entire team proud when we managed to achieve something like this. You can write a simple user-defined function. In this case, this is a user-defined function that takes two parameters. One is a nullable integer, the other one is a string, and returns a string. And what it does is, it's basically saying expect two parameters. One is an age, the other one is name. Just go ahead and concatenate it and return it back. And here's where something interesting happens. Now you can take this user-defined function and basically give it to Spark. You're now saying dataframe.filter. You're providing some kind of predicates in order to filter your data based on this criteria that I only want to select records which are greater than 21 years old, essentially, right? And then you're saying select, and then you're passing in the user-defined function that you defined into Spark. And I want you to take a moment to notice what we just did. Without any difficulty, we took a user-defined function, gave it to Spark, and now Spark can automatically parallelize this across 10 cores or even thousands of cores, essentially. So that is one really nice thing that you end up getting with this kind of a library. It simplifies the entire abstraction and allows you to focus mostly on your business logic. Having said that, you might be wondering at this stage, hey, what am I going to lose? Like, it looks like Scala is written in the JVM, Scala being the primary language. What am I going to lose? Well, you're not going to lose much. So for comparison, just to kind of make a point here, the left side here shows a TPC-H Query 2 written in Scala. TPC-H, for those who are not familiar with, is a standard industrial benchmark. It's a collection of 22 queries, and you'll have to kind of show that your system passes those 22 queries for it to be useful in any real production use cases. What you notice here is the left side shows a Scala example, and the right side shows the exact same example written in C#. You can take a moment to see what exactly are the differences here, and you'll immediately notice it's dangerously copy-paste friendly, and the team has been very conscious about allowing and encouraging you to do this, because we do want you to search on Google. We want you to search pretty much anywhere on the internet, go to Stack Overflow, copy paste the examples, and just change very trivial things in order to make the example run on top of C#. The second piece you will notice is there are subtle differences, like the way you would address a particular column. And finally, some bits and pieces about capitalization. But I'm not kidding. The 22 queries of TPC-H, it literally took me about less than an hour to copy paste from Scala into C# and just change them to actually make them work inside C#. And I'm pretty sure you're going to love the experience. Having said that, if you're familiar with Spark at all, you would be very familiar with this particular thing called a Spark Submit. What it does is it's a small companion tool that comes with the Spark distribution itself, which allows you to specify what is the entry point of your application, along with what is the user jar that will host your application logic and any particular arguments to your app. Now, one of the nice things that our team has done is .NET for Apache Spark does not modify Spark core at all. The biggest advantage that you end up getting by having something like this is you can take exactly the same Spark Submit companion app that comes with the open source Spark. You just change these two minor things. One, whatever is highlighted in yellow here is the one that's provided by the .NET for Spark library. You don't need to change this at all. The other piece, this piece is the one that you would pretty much specify with your application executable, and that's basically it. This is how you would end up running it. And let me show you quickly how we end up doing that. So in this case, the whole code is available under .NET/Spark. You can basically go here, browse around for examples. You can basically also see, how do you go ahead and build or get started on any of the three major operating systems. Again, I do encourage you to kind of try out, but an easier way to start would be the .NET Spark homepage. Once you get to the home page, you just do a the get started piece, and we've put in a lot of thought in terms of simplifying the entire thing. There's also a video that is accompanying these instructions in case you prefer a video style. And what I've done before this talk is something as simple as just go ahead and install .NET Core, install a bunch of prerequisites. There's not many, like there's just the Java runtime that you need on your machine. Again, if you choose to develop using a cloud provider, you don't really need any of this stuff. And the one thing that I've done is I've gone ahead and downloaded Apache Spark onto my machine, and I've just followed the instructions here. Basically, there is nothing else that I've done here. Now, once I do this, one of the nice things here is I set some environment variables, specifically these pieces. Right after that, you can use whatever .NET knowledge that you already have in order to go ahead, create a new console application, and basically just CD into that. So essentially, those are the steps that I've done before beginning this talk. And I've landed into my favorite IDE, which is VS Code. And all I've done just to convince you here is I have a very simple project. All I've done is there is a program.cs. I've copy pasted the same example from that that website that I've just shown you, and I'll cover what this actually does. And I've also created this input.txt file here. This input.txt file, it basically contains a bunch of things, and I'll run you through what exactly this sample app does. Like I said in my talk, I go ahead and create a Spark session. Once I create the Spark session, I'm basically telling Spark, go ahead and read my file. My file is in the text format, and here's the path I want you to read that file from. Right after that, I'm going ahead and invoking operations that look very analogous to LINQ or SQL. And you're actually right when you guess the thing. Like you will see Spark is heavily inspired from LINQ, and you'll see a lot of syntax which is very analogous to LINQ itself. In this case, what I'm doing is I'm taking the data frame, I'm doing a bunch of transformations using select, and I'm doing a group by. Why? Because I want to count the frequency of each of the individual words, and I'm doing a count right here, and I'm finally ordering it by this particular column. And I'm instructing Spark, go ahead and show me what you have. And I'm stopping my session. It's as simple as that. Now, when I run it, all I need to do is I just need to do .NET build. Once this gets built, essentially what I can do is I can just go here, and there is one command that I had shown you in the previous slide. This command, what it is doing is it's basically going and specifying the fixed parameters that I've shown you inside the slide, and it's using the latest version, which is 1.0, and it's specifying this is my application and this is my parameter. Let me go ahead and run that, and you will see now what's going on is this particular command is invoking my C# application to leverage the underlying, the Apache Spark binaries that I've actually downloaded locally onto my machine. The first time that I'm running this, it takes like a couple of seconds for it to initialize and whatnot. But you will see very shortly that there's going to be like a flurry of messages that get printed out on the console. And if everything goes well, you will end up seeing some of the output that gets printed out here. So like I mentioned, you will see some debug information that gets started. And what's happening in the backend is we've taken very, very good measures to make sure all the complexity gets hidden behind the scenes. You will not really know what's really happening on the Spark side. What does it take to kind of start all of those pieces? Here, it ended up going ahead and running Spark, and you get like a first-class C# experience. You did not have to really know anything on the Java or Scala side. Don't be worried about the logs that are getting printed. Spark is quite chatty, as you can already see it. If you can see here, what just happened is I took that input file and I managed to just go ahead and print the word count. It's as simple as that. And we do have some other demos that show you some of the nicer, cooler new things that we have actually built. So the one other thing that we've been doing is we've been in contact with the community quite a lot. We've been doing quite a lot of surveys to actually understand what is it that our users want. And I'll now hand over to my colleague to present some of the results from our developer survey.
Sure thing. We are on the developer survey. If we want to switch to my share, I'll advance from here. So we reached out, especially around, we just went to a 1.0 version. So we were pretty excited to hear from the community and understand exactly how they're using Spark. We got just over 200 responses, and the majority of those respondents were developers and architects. You can see the breakdown here. What was interesting to us is Python, Scala, Spark, SQL are sort of the out of the box languages and have been around for quite some time and are preferred to be used for that. So it was exciting to see that we had a 30% or 1 out of 3 using C# now, which means that .NET for Spark is making some inroads. We actually have some F# usage as well. So F# users are plugging into the .NET for Spark paradigm. As far as platforms, we noticed that 2 times the number of people were using Visual Studio compared to Visual Studio Code, and 70% were running on .NET Core. And the team was looking at, are these workloads mostly run on .NET Framework, .NET Core? And it turns out there are a significant amount that are on the .NET Framework, but a vast majority are on .NET Core. And then we went across the board. We asked a lot of questions, but we wanted to know what scenarios are people using for big data and .NET for Spark. And it turns out the common scenarios are extract, transform, load, analytics, and data warehouse. Now the challenges, it's interesting, the challenges for big data in general and specific to .NET for Spark were the same. People said that the dependencies and the setup was a challenge. There were a lot of prerequisites, and documentation was a challenge. And I'm happy to say we were already on the path to address both challenges. Our documentation has been completely updated. That's been rolled out. But I'm going to talk about dependencies and setup in a second, so we'll come back to that. As far as requested features, so where do we want to take .NET for Spark? A top feature was deployment from Visual Studio, being able to do that Spark submit as something as simple as a right-click gesture. Another is integrating with CI/CD for those who don't right-click deploy, right? And the other is integration with ML.NET. And to be clear, .NET for Spark allows you to use any of your .NET libraries. So you can today take advantage of ML for .NET in those jobs. This integration is tighter integration between data frames and sharing data between the 2 tools. Now, one of the nice things about .NET for Spark being open source is we get these amazing community contributions. And one of those that's helping us close that inner development loop is this community contribution of a set of Docker images. So there's several Docker images that out of the box create that environment. And that is actually perfect for me because I have a brand new laptop and I did not install Java. I did not install Spark. So I have none of those tools on my machine. I'm going to pop over to Visual Studio Code and I'm going to show you a program. It's very similar to Rahul's. I obviously stole it and modified it, but I took some of the text from the .NET conference site. That's what's in this text file. And in my program, I updated it to a .NET 5, so we have a top-level program. But it's doing the same thing. It's creating a Spark session. It's grabbing a file. It's doing the word count, and it's stopping. Now, if I hit F5 right now, we can go ahead and see what's going to happen. It's going to build. It's a typical .NET project. It's going to try to run it, and we're going to immediately fail because there's no connection to be made. There's no Spark running on my system. It has nothing to attach to. I have a Docker extension here, and all I did prior to this was I did a Docker pull on this .NET Spark image. So I have that Docker image on my machine. So what I'm going to do is right click from Visual Studio. Actually, I need to get to the tag and go ahead and tell it to run that. So it's going to launch that Docker container for me. And you can see the containers up here now. And I'm just going to do one quick thing in the terminal. This job is going to run inside of the container, so it needs to be able to see the file that we're counting. So I'm going to do a Docker PS, which shows me the running containers. And then I'm going to do a Docker CP, which will copy the .NET text file to the container. And I'm just giving it enough to uniquely identify the container. And it's .NET debug is the path. So all we've done is we've just dropped that text file into the container. So I'm going to pop out of this, and I'm going to do the same thing I did before, and that's hit F5 and run this. And what's going to happen now is because that container is running on a known Spark port, that Spark session is going to be able to actually request the session and start a session. You can see I've had a breakpoint, and we've stopped on my breakpoint right here. Right now the words are null. If I do F10 to step over, now we've got a data frame here inside of the words. Let's do the show. We'll step over that, and I'm just going to expand my console so we can see the output. And there's our word count. And obviously it's from the .NET conference site, so we would expect .NET to be one of the top counted words. But that's just an example of things we're doing to close that inner loop. I was able to .NET new, type in a program, run a Docker container, and have that Spark experience right away. I'm going to turn it back over to Rahul now.
Thanks a lot, Jeremy. Wasn't that wonderful? Our contributor, Martin, when he showed us that particular how he actually built some of that Docker pieces, it honestly blew our mind. And that's one of the really cool things about open source as well, right? I think the project, the .NET for Spark project, builds quite heftily on the shoulders of many of our contributors who have taken a lot of time to contribute some really awesome pieces into the library itself. And now I will take a moment to explain like some of these pieces, essentially, like specifically what are the updates that we would like to kind of give to the entire community itself. First, there's also like a pretty hefty contribution that came out, which is support for Spark's MLLID. And you should really check this out. I will not do justice to explaining any of the stuff because I'm not a machine learning person. We build platforms for machine learning, but I highly encourage that you folks, if you're interested in how would you do machine learning in a distributed fashion, like using Spark's MLLID implementation of machine learning algorithms, we highly recommend that you check out some of the new contributions that came into .NET for Spark. The second piece is, over the last 2 years, we've been working extremely closely with some of the massive teams inside Microsoft. One to specifically name is the Office team. And there is a team called MSAI, which is responsible for Microsoft search, assistance, and intelligence, and everything that powers some of the really cool new features that are coming out of Outlook. And one of the things is they are now using .NET for Spark in production consistently well for the last year or so, running regularly on workloads of size pretty much 50 terabytes every couple of days. And that is just one team. There are many other teams that have adopted inside Microsoft, and that's what has given us ultra high confidence that, yes, I think this library is ready for production use. Yes, we will still find like a couple of bugs or two, but we did manage to get a number of people tell us that they truly love the experience that they end up getting with .NET for Spark. And that is the main thing that has given us the confidence to release the latest version, and that's version 1.0. On behalf of the entire team, I would like to announce the .NET for Apache Spark latest version, which is version 1.0. It comes after a lot of hard work from all the community members and almost like close to 300 pull requests that have been merged. There are 42 project contributors, and we've had like a number of NuGet downloads and GitHub stars. So thanks a lot to both our users for reporting all sorts of problems and also our contributors. And rest assured, this is exactly the same pieces that are also made available in some of our newer products that we're releasing called Azure Synapse Analytics, which I will give you a very brief introduction. But before I go into that piece, I do want to kind of call out all of the community members. Thanks a lot, folks. Like without the help from each and every person listed here, and also some of the people that I may have subconsciously missed, this project would not have really reached this particular milestone. And for that, like the team and myself especially are eternally grateful for all of the help. And added to that, one of the really awesome things is the library is cross-platform. It works on Windows, Ubuntu, and Mac, and it's also cross-cloud. It works with pretty much like every other cloud provider that you can imagine, like who offers Spark. Yes, you may hit into like a problem or two, but that's because like we don't really have visibility into how the Spark runtimes are evolving in each of these cloud providers. But you will see that our team is extremely active on GitHub. I highly recommend that you come and chat with us on GitHub if you have any issues with anything that's running on any cloud, no matter what. Having said that, I also want to take a brief moment to just stick this in here, which is Azure Synapse Analytics is one of the latest products from the Azure team, which allows you to do pretty much anything that has to do with data management or big data in like a super simplistic way. And .NET for Spark is available as a first class citizen. Why do I say first class? Like, why not the demo that I've shown you or like the one that Jeremy has shown you, right? Let me take a moment to explain briefly what exactly I mean by first class. So Synapse is a huge ecosystem. And today what we're going to do is, obviously, I will not have time to talk about everything inside Synapse, but feel free to ask me any questions in like the Q&A. But we will be talking about the specific Spark portion right here. So with this, let me just deep dive into Synapse just to show you what you will end up getting. All I've done is before this demo, you can go into this piece, you can just type Synapse here, and you can create a workspace. And your entry point into everything starts with the Synapse workspace. So once I've created the workspace, this is my workspace. This is the homepage that you're going to end up seeing. You can click around everywhere. It's really a pleasure to explore Synapse. Honestly, like I'm really thrilled that we as Microsoft are actually building a product like this. And if you start looking into some of the experiences here, what I can do is I can go into develop and I can start writing notebooks. And you will immediately see that once I click notebook, this is what I mean by first class. What you can now do is you can basically select .NET Spark. And for this, I'd like to call out huge kudos to the .NET Interactive team. We've worked very hard with the team very closely over the last 1 year to give you a first-class REPL experience. You can start kind of just writing C# code right here. And everything will just work as expected right there. Of course, I'm not going to show you console.writeline, but there is a very awesome guide that I recommend that you check out. And everything is documented right here. All the links I'm going to show you. But as Jeremy was hinting at, you can use the whole power of .NET ecosystem that's out there. You can install NuGet libraries, and I can show you very quickly in terms of the experience that you're going to end up getting inside the notebook itself. One of the cool things is you will be able to use this semantic called #R. Like you can see, of course, I'm jumping way ahead, but you can see I can plot, I can do some really crazy things inside this REPL. And what you will also notice is, there's not really any features that are missing right here. And of course, you can extend things in ways that we have not even imagined in the first place. And if you go in, you can also use some of the latest developments from the community in the form of Apache Arrow, which is more memory optimized for transferring data from the Spark runtime into your C# runtime. If that's not your thing, and if you just want to install some libraries from NuGet, you can do something like #R, specify the name of the library, and you're good to go. Essentially, you can basically register it as a user-defined function. And look here, right? I'm actually doing some matrix multiplications right here, and I'm calling all of that code using Spark. And that should give you hopefully like a brief intro to the power that you end up getting with these kinds of integration. And with that, let me switch back here. I'd like to conclude this talk. I'm very, very happy to take like any questions for me. I've included a bunch of links here. If you are curious, like what can you actually do in order to immediately get started? With that, I'll open this up for a Q&A. Thanks a lot.
All right, thank you all so much. Really appreciate you sharing that stuff with us. And Jeremy, information you shared with like the metrics and whatnot was really cool. But I do want to remind you, man, like friends don't let friends right-click publish, right? So make sure you use your CI/CD. You know, kind of like how don't let friends use tabs over spaces. We don't allow that kind of stuff over here. So
Right.
that being said, we do have to keep it going. We do have a few questions that y'all got, but we don't have time to get to those at the moment. So Jeremy and Raul, if you don't mind, probably like after you get off, would you mind heading over to Twitter, you know, answering some of these questions that these folks have asked? Like, there's a lot of great questions here.
Yeah, I see Twitter right
right
over here. I'm gonna head over there right now.
Yeah, like just go over, just knock on the door and tell them I sent you, and then we'll be good to go.